WR104 is a young star system consisting of a Wolf-Rayet star and two hot blue main sequence stars. The system lies about 8,400 light-years from Earth in the constellation Sagittarius. The Wolf-Rayet star is expected to end its life as a supernova in the next few 100,000 years. When it does, there is a slight chance that it may produce a long-duration gamma-ray burst approximately in the direction of Earth. WR104 is surrounded by a distinctive dusty Wolf-Rayet nebula, over 200 astronomical units in diameter, formed by interaction between the stellar winds of the two stars as they rotate and orbit. The spiral appearance of the nebula has led to the name Pinwheel Nebula being used. The Wolf-Rayet star has a mass 10 times of the Sun and a radius 3.29 times bigger. It is 40,000 times more luminous than the Sun, with an effective temperature of about 45,000 Kelvin. The star has the stellar classification WC9d. The C indicates dominant lines of ionized carbon, while the suffix D indicates dust in the star's spectrum. The spiral structure of the nebula is composed of dust that would be prevented from forming by WR104's intense radiation were it not for the star's companion. The region where the stellar wind from the two massive stars interacts compresses the material enough for the dust to form, and the rotation of the system causes the spiral-shaped pattern. The round appearance of the spiral leads to the conclusion that the system is seen almost pole-on, and an almost circular orbital period of 220 days had been assumed from the pinwheel outflow pattern. WR104 shows frequent eclipse events, as well as other irregular variations in brightness. The undisturbed apparent magnitude is around 12.7, but the star is rarely at that level. The eclipses are believed to be caused by dust formed from expelled material, not by the companion star. Supernova progenitor. Both stars in the WR104 system are predicted to end their days as core collapse supernova. The Wolf-Rayet star is in the final phase of its life cycle and is expected to turn into a supernova much sooner than the OB star. It is predicted to occur at some point within the next few 100,000 years. With the relatively close proximity to the solar system, the question of whether WR104 will pose a future danger to life on Earth has been raised. Apart from a core collapse supernova, astrophysicists have speculated about whether WR104 star has the potential to cause a gamma-ray burst at the end of its life. The companion OB star certainly has the potential, but the Wolf-Rayet star is likely to go supernova much sooner. There remain too many uncertainties and unknown parameters for any reliable prediction, and only sketchy estimates of a GRB scenario for WR104 have been published. Wolf-Rayet stars with a sufficiently high spin velocity, prior to going supernova, could produce a long-duration gamma-ray burst, beaming high-energy radiation along its rotational axis into oppositely directed relativistic jets. Presently, mechanisms for the generation of GRB emissions are not fully understood, but it is considered that there is a small chance that the Wolf-Rayet component of WR104 may become one when it goes supernova. If neither of the supernova produced by the two stars generate a GRB, their compact stars will. If they both become neutron stars, or one of them becomes a black hole, the other should be a neutron star, the collision of the two compact stars will generate a gamma-ray burst. Effects on Earth. According to available astrophysical data for both WR104 and its companion, eventually both stars will finally be destroyed as highly directional anisotropic supernovae, producing concentrated radiative emissions as narrow relativistic jets. Theoretical studies of such supernovae suggest jet formation aligns with the rotational axis of its progenitor star and its eventual stellar remnant, and will preferentially eject matter along their polar axes. If these jets happen to be aimed towards our solar system, Its consequences could significantly harm life on Earth and its biosphere, whose true impact depends on the amount of radiation received, the number of energetic particles, and the source's distance. Knowing that the inclination of the binary system containing WL104 is roughly 12 degrees relative to line of sight, and assuming both stars have their rotational axes similarly orientated, suggests some potential risk. Recent studies suggest these effects pose a highly unlikely danger to life on Earth, with which, as stated by Australian astronomer Peter Tuthill, the Wolf-Rayet star would have to undergo an extraordinary string of successive events. The Wolf-Rayet star would have to generate a gamma-ray burst, however. These events are mostly associated with galaxies with a low metallicity, and haven't yet been observed in our Milky Way galaxy. Some astronomers believe it unlikely that WL104 will generate a gamma-ray burst. Tuthill tentatively estimates the probability for any kind of gamma-ray burst event is around the level of 1%, but cautions more research is needed to be confident. The rotational axis of the Wolf-Rayet star would have to be pointed in the direction of our planet. The star's axis is estimated to be close to the axis of the binary orbit of WL104. Observations of the spiral plume are consistent with an orbital pole angle of anywhere from 0 to 16 degrees relative to the Earth, but a spectrographic observation suggests a significantly larger, and therefore less dangerous angle of 30 to 40 degrees, possibly as much as 45 degrees. Estimates of the opening angle jet's arc currently range from 2 to 20 degrees. The jet would have to reach far enough in order to damage life on Earth. The narrower the jet appears, the farther it will reach, but the less likely it is to hit Earth. If you enjoyed watching this video, then hit that subscribe button. You could even like the video or leave a comment. Thanks for watching.